Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this short video, I will try and discuss few of the formulas that you use in coordinate geometry. One of the formulas that you must be able to use is the midpoint formula. This is something you use in situations where you are being provided two coordinates and you have to find out the midpoint of those coordinates, the point that is exactly halfway between the 2 points. So quite obviously that particular point will have an x value which is average of these two exterior x values, and y value which will be average of the two exterior y values as well. So the formula is quite obvious that you will find out the midpoint by using x1 plus x2 upon 2, that will get you the x coordinate of the midpoint, and y1 plus y2 upon 2, that will get you the y coordinate of the midpoint. And that's basically how you find out the midpoint. Let's have a look at few examples, like you're given coordinates like 2, -1, 3 and 5, and you have to find their midpoints. So the x coordinate will be 2 plus 3 upon 2, and y coordinate will be -1 plus 5 upon 2. This simplifies as 2.5, and the y coordinate simplifies as 2. So that gets you the midpoint of these two exterior coordinates. You can also use this in a situation where you know the midpoint, you know one of the exterior points, and you have to find out the other exterior point. Like for instance, this is the midpoint and P is 5 minus 2, and we have to find out the other point Q. So what we can do is that we can suppose the other exterior point Q as x1 and y1, and we will know that this midpoint would be average of this point and this point. So x coordinate will be 5 plus x1 divided by 2, and y coordinate would be -2 plus y1 upon 2. And once we are able to find out the midpoint in terms of x1 and y1, since we already know that the midpoint is 4, 7, so we can equate it to 4 and 7. And you can make actually two equations out of it, because you can equate x coordinates together and you can also equate y coordinates together. So that gets you one equation as x1 plus 5 upon 2 being equated to 4, and y1 minus 2 upon 2 being equated to 7, and hence you can find out the two coordinates. One more situation where you use this formula a lot is basically where you know three vertices of a parallelogram and you have to find out the fourth vertex. You must know that if you have a parallelogram as a figure, and also do identify that rectangle is also considered in the category of a parallelogram. A square is also considered as a parallelogram, or even if you have a rhombus, that would also be considered as a parallelogram. So for all of these figures, whichever diagram is a parallelogram, the midpoints of the opposite diagonals are supposed to be same. So if you don't know one of the vertices, what you can do is that you will find out the midpoint of one diagonal, in this case P and R, and equate it to the midpoint of the other diagonal, in this case that is Q and S. And since you don't know one of the coordinates, you will get two unknowns over here, and you can find those unknowns by equating the x coordinates together and the y coordinates together. So as you equate x coordinates together, you will get x coordinate of the unknown point, and if you equate y coordinates, you will get the y coordinate of the unknown point. That's how you can use this formula. The other formula that you can be using in the chapter of coordinate geometry is the distance formula. If you are provided 2 points and you have to find out the distance, the length of the distance between these 2 points, then you have this distance formula. By the way, this distance formula is basically derived from the Pythagoras theorem. Like if one point has coordinate x1, y1, and the other point has coordinate x2, y2, then this base is going to be the difference of x coordinates. So that will be x2 minus x1. And this height will be the difference of y coordinates. So that means that is going to be y2 minus y1. So if you are able to identify this side and this side, this is actually forming a right angle triangle. So if you apply Pythagoras theorem onto it, then you can say that d square must be equal to x2 minus x1 whole square plus y2 minus y1 whole square. And then you can take square root on both sides and you can get yourself the distance. So this is basically your distance formula. In most cases, almost all of the cases, you wouldn't need to derive the formula, you would just need to use the formula. So like for instance, I know two coordinates and I have to find out the distance between these 2 points. So I'm going to say the distance is going to be x2 minus x1 whole square. So you just have to be a little careful that from x coordinate you have to subtract the x coordinate, and from y coordinate you have to subtract the y coordinate. In this particular case, the order really doesn't matter, because quite obviously distance from one point to the other is equal to the distance from other point to the first point. So it wouldn't matter much that in what order you're choosing the point, but you just have to make sure that you subtract x coordinates together and don't make a mistake of subtracting x with y. And you subtract the y coordinates together, square them up, and you will be able to get yourself the distance. Third formula that you should know is the gradient or the slope formula. This is basically somewhat a measure of how steep a line is. So if a particular line, you find out its gradient and it has a larger magnitude, so that shows that the line is more steep. So if you find the value of gradient lesser, so that means, or the magnitude of the gradient lesser, that shows that the line is less steep. And we also must be able to identify that the sign of the gradient tells me whether the line is sloping up or down. So a positive gradient means that this line is sloping up. That means it's going up when I show an increase in x. Whereas if the line has a gradient negative, that means it's sloping down, which means if I go for an increase in x, the value of y would decrease. So a more steep line will have a larger magnitude of the gradient. If the line is sloping down, its gradient would be negative. If the line is sloping up, its gradient would be positive. Plus, there are a couple of things. You don't apply the formula for a line which is exactly horizontal or the line which is exactly vertical. And you must know that a horizontal line has zero gradient. And vertical line has a very large gradient. In math, we call a very large value as infinite. So the vertical line has an infinite gradient and a horizontal line would have a zero gradient. Now, the formula to find out the gradient is y2 minus y1 over x2 minus x1. It's basically the change in y over the change in x. So if you have 2 points on the line, y2 minus y1 gives you change in y, and x2 minus x1 gives you change in x. And that will get you the gradient. The ratio of that will get you the gradient, which is y2 minus y1 over x2 minus x1. And if you look at it closely, again treating it like a right angle triangle, then you would be able to identify that y2 minus y1 is the vertical height and x2 minus x1 is the horizontal length, which will mean that this is also equal to the tan ratio of the line. The tan ratio is perpendicular over base, in this case height over base. So for a line, if it makes an angle theta with the horizontal, then you can also say that gradient is equal to tan theta. The formula is, again specifically, y2 minus y1 over x2 minus x1. So what you would do is, again, not make a mistake of mixing x and y's together. Numerator has to be the y coordinates and the difference of the y coordinates. And again, here it is going to be important that you make sure that what you assign as x1, y1 and what you assign as x2, y2. What I mean to say is that even if you don't mix x and y together, but if you take 3 minus negative 4, but by mistake you take 7 minus 1, that will be wrong. So if you're subtracting second point from the first point, you have to be consistent with both x and y. So here, if I have these two coordinates, I'll find out the gradient by y2 minus y1, that will be 7 minus 1, and I'll find out the difference of x coordinate, that will be, in this case, minus 4 minus 3, and that tells me the gradient. Also do remember, because this is something we will use later on in our further discussions as well, but also do remember that if the line makes an angle theta with the horizontal, then the gradient can directly be equated to tan theta. Here you can look at few examples, like if I am given these coordinates, I could be asked to find out the midpoint, so I'll use the average of x and y coordinates. If I have to find out the gradient, I'll use the formula y2 minus y1 over x2 minus x1, and in case if I have to find distance formula, I do under root x2 minus x1 whole square plus y2 minus y1 whole square. So this basically just shows or demonstrates how you have to apply these formulas. Thank you everyone. I hope you liked the video. If it was helpful, please do like and subscribe to the channel. Thank you.